Okay. So let's just look at our code so we remember what we did. All right. So remember that we made 3 instance variables here. We put our player, we made our player inside of our flaw file. And then we used the state variable called move down that kept the state of true when we're moving down the screen, when our player is moving down. And then he was false when we're moving up. And so that was so that our click function would work. Okay, so that we didn't have to keep clicking, remember? So if we had the state variable move down, he kept the state of our game, whether we're moving down or up. Okay, that's called like a state variable. Remember, he's a Boolean type, so he could be either true or false. And then we made our ball object. Okay. And our ball we created in our flaw file. And then we copied and pasted these variables so that we could get the ball movement. We went ahead and copied and pasted that code, remember. So we had to make these instance variables at the top of our code. And then our constructor function, remember that this is the function that's run when we start, and it's where we instantiate our member variables. So we made the new player, set his y value. We didn't have to set his x value. Remember why? Because he was smack dab against the left-hand side. So his x was 0, and that was good. Okay. And then we added him to the stage. We created our Boolean variable, and we went ahead and made the default equal to true. And then we made our ball variable and added him to the stage. And we added him to the middle of the stage with these 2 lines, remember. Okay. And then we added 2 event listeners. One was our click function. Remember, we used our click function for our movement up and down. So if they click above the paddle, it moved up, and below the paddle, it moved down. And then our enter frame was our clock for our game. Remember, we always have to have some kind of timer for our games. And so we usually use that enter frame event. All right. Now when we move our player, it was pretty easy to move him. Okay. So when we move our player, we're listening to that click function. So remember that this function was the function that is run whenever we click the mouse, or when we go to our e-pads, it's whenever we're going to tap on the screen. Remember, click translates to tap. And so this function is run every time we tap the screen, so it's going to change the movement of our player. And we had a couple branching statements. Remember, these are called our branches. We have the if, and then in the parentheses our Boolean. And in here we just checked to see if where we clicked. So remember that this e variable is the parameter that's passed in, so that tells us where our finger has touched the screen or where the mouse has touched the screen, the x and y value for that. And so we can bring up that property right here. So we say e.stageY tells us where our finger is touched on the screen, on the stage. And if it's below the player's y, meaning less than the player's y, which actually means above the paddle, because remember our y direction goes positively downward. Okay, so it's above the paddle. Then we set that move down variable to false. And then our player 1's y, we subtracted 10 from him. Remember, that moves him up the screen 10 pixels. And we actually could have made this an else part, but we went ahead and made another branch here. So then if we tapped below the player, meaning that our e variable where we touch the screen is greater than the y value of our paddle, our player. Then we set that state variable move down to true, and our player 1's y value we add 10, which moves him down 10 pixels on the screen. And then remember that our on-frame enter method is called 24 times a second. Okay, remember that's how we kind of used him as a timer. And we just check to see right here if the player 1's And remember that we added this code here so that we wouldn't go off the stage. Okay. Remember that was kind of a long Boolean statement, and we learned about our AND operator, our AND logical operator. So both Boolean statements had to be true. It's how you connect two Boolean statements. So we can look at our Boolean statements. We made them sort of long, but so we check the player Y's value. If it's less than the stage height minus the player height divided by 2. So remember that our crosshairs for our player were in the middle of the player, so that's why we had to actually subtract that value. So meaning that he's reached the bottom of the stage, or if he's reached the top of the stage. That's what this is checking. Okay. And if he is in the move down state, so if that is a true value and move down, we add 10 pixels to our player 1's Y value. Otherwise, we subtract 10. So we either move him down. If move down is true, it moves him down. And if it's false, he moves up 10 pixels. Remember that this is happening 24 times a second. Okay? And so that's what keeps our player moving down and moving up. All right. And then we wrote this method, or this function called ball movement. And in our ball movement function, we pretty much copy and pasted it, and we commented it. So I'm not going to go through it too much, but remember that you can play around with these numbers. I would change one number at a time to see how it changes your game, and you can start to see how this code works. You could even modify and improve it. It does have some flaws, so you might have noticed it kind of overruns the paddle sometimes, actually. And all right, and then we commented out this last part of the code because we hadn't put our enemy in our game yet. And that was our code. All right, so everybody kind of remembers the code now? Yes? Any questions on our code? All right, cool. So I think our first step is to add our enemy and get him to work with some artificial intelligence. All right, so go ahead and open up your flaw file, and we're just going to create our enemy as an enemy movie clip object. We could just add him as another player, but then when we want to differentiate our enemy from our player, it'll be easier if they're separate movie clip types. So we'll make a new movie clip. So right now, you could just make it as a rectangle, kind of like how we made our player object. Remember that we can exchange him later. In fact, that's what we'll go over today, how to exchange him out for a better looking enemy. But just make a rectangle, of course. And then select that rectangle. And of course, make him a movie clip so that we can add him through our code so that he can have movement. I'm going to go ahead and call him enemy. Now remember that when you name these movie clip objects, you should name them with a capital letter. Okay, if we get into the habit of doing this, it makes a lot of sense and our code will work better. And remember to export for ActionScript in there if you didn't already. All right. And then you'll see him over here on the left so that I can delete that instance from my stage because he's stored in our library. All right. Now I know you guys already know what to do next, right? What are we going to do next? We need to add an instance of him into our code so that he can appear. And we need to put him in the right place. And I bet you guys could probably almost figure that out. We should be getting good at this now. Okay. So remember that we add him through our ActionScript file. So we can go up here where our instance variables, where we've created them, and make a new one. Now remember that we name our variables with a lowercase letter, and then we name our movie clip object types with a capital letter. So remember that we're allowed to do things like this. Remember that these are two separate things because ActionScript is case sensitive. So this is a totally different word than this word, okay? This is our movie clip type, and this is our variable name. Remember that you can name your variable name anything, but a lot of times I just name them the same name with a lowercase letter. Okay? It just makes it easier to read your code. All right, so this is where we declare him. This is called our declaration, remember? And remember that we instantiate him in our, what's the name of that function? You guys remember? Constructor, yes. Remember that our constructor has the same name as our class. And this is the code that's run when we start our game. This is a constructor code. We need to start remembering things like this because we do actually have to have a test in here eventually. We'll have to look at our schedule. All right. So we instantiate our enemy, by putting his name, putting the assignment operator, putting the new operator, and then actually calling the enemy constructor. Remember, that's our constructor for our enemy, and it constructs or creates that new enemy object inside of our main memory inside of our computer. And then we set his X and Y value. Now where do we want our enemy to appear? We want him to appear on the right-hand side of our stage. So think what his X value should be. Actually, let's look at our enemy so we can figure that out. All right. In fact, we could modify this enemy so that his crosshair is on the right-hand side of him. And do you remember how to modify our enemies or any kind of movie clip in a flaw? Remember that we double-click on them. So I'm going to modify my enemy so that his crosshair is on the right side of him. It doesn't matter that much. You could leave it on the left side, but then you'll have to calculate how to place him on the stage. But if you want to move, remember that the crosshair here, this little plus sign up here is his reference point. That's his XY reference point. So if I double click on him, I can then put his reference point on the right side of him. And so then I just drug him. Remember that you have to double click on him first. So you have to look up here on scene 1, make sure you're inside of the enemy object. And then you can drag him so that his reference point maybe is on the back side of him, on the right side. And that modifies him. Remember to get out of edit mode, you can go up here and hit scene 1 up in the top left-hand corner. That's how you get out of your edit mode, remember. Okay, so then we have his reference point in the right place, or in a better place. So now I can think where to put my X value. If his reference point's over there on the right, that's where it's going to put his X. So where should I put him on the stage? Anybody? Where should we put him on the stage? What should his X value be? Stage dot stage width. Because remember that'll put that little hashtag, or that, not hashtag, little plus sign on the right. So stage width. Now remember his Y value is his vertical placement on our stage. So enemy.y. And I actually can copy this from over here. So his Y value can be the same as our ball and the same, well, we'll just say the same as our ball. And then very importantly, we need to add him. So you remember that you create him or instantiate him, you change his X and Y. And then you do your add child call, your stage.add child. Remember you can double click, Control C, double click Control V. And we could save it and run it and make sure it works. We like to test as we go. Okay, so we can get rid of our syntax errors early. So you can do a Control S save, Control Enter run. Oh, and I left that other guy on the stage, so he's still on the stage. But you can see that my enemy that I've added through my code is over here on the right-hand side of my stage. If you were like me and you left the other one in the flaw file, just go over to your flaw file and delete him. And there he is. Oh, and I won. Okay. Now I won because my enemy wasn't moving. So we need to add some movement to our enemy. Now, to move our enemy, we're going to use a little bit of what's called artificial intelligence. It's going to move, the enemy is going to move himself. And so I'm going to cheat and kind of copy and paste this function. And then as you guys are copying it, we will go over what it does. So remember to add this function, add this new you guys are going to write this new function after all of your other functions. So this is why we labeled our closing curly brackets, but you put it before the end of your class, remember. So I'm just going to paste them in here. I called it public, public function AI movement. And actually, he doesn't need this, so I'm going to get rid of my parameter now. And he returns void because he's not returning anything. And notice that inside of this function, we just have a couple of branching statements. And we should be getting better at reading these branching statements. Remember that ActionScript 3 is actually pretty readable code. Okay, and we can add comments in here to tell ourselves what it's doing. So our first branching statement says, if ball.y is greater than enemy.y. So what is that telling us? Ball.y is greater than enemy.y. So that means the ball's y value, so where the ball is located vertically on the screen, is bigger than the enemy.y. So that means he's below our enemy. Because remember that the positive y values increase as we go down. So that means the ball's y value, or his crosshair, or his reference is below the paddle of the enemy. Okay? So what would we need to do? We need to move the enemy down to catch that ball. Okay? Now, we don't want him always to win. Okay, so actually we can take the math.random out right now and see him always win. So I'm going to go ahead and take this out. Let's see him always win first, and then we'll realize why we need that math.random there. If we make him too perfect, he will always move in the correct location and always catch the ball, and we'll never win. Because he knows where the ball's y value is because we're telling him. There's no room for error. Like us humans have room for error. Our randomness comes from our room for error. We can't click fast enough, right? We're not clicking fast enough. But a ball programmed in here, you can make a perfect AI that he always wins. Okay. So what do we do? So if the ball is below the enemy, we need to move that enemy down. We need to increase his y value. And I think we've seen this code before, that plus equal sign. Remember that you can write this a different way. And I'm just going to write it in the long version up here. Because I got rid of the random, the 5 plus 1 looks a little silly, but So remember that what you do when you see the plus equal sign, you take the old value of enemy.y, you add 6 to that value, and then you place that amount back into enemy.y. So that'll become his new value. So the plus equal is how we add things to a variable or to that y value. Okay, so I just wrote it in the longer form as comments. So in my comment up here, I will say the ball is below the enemy paddle, so move the enemy down. It's good to comment our code, so then we remember it when we come back to it. All right. So obviously, this other if statement, you can think the ball is above the enemy paddle, so we need to move the enemy up. So if our ball's y is less than enemy y, remember that we go less, our y values are 0 at the top, right? So if ball's y value is above him, it'll be less than the enemy's y. And so then we move our enemy up the screen by subtracting 6 right now. And then we'll put our random in there in a second. Okay? Now this function AI movement, it's not going to run unless we call it somewhere. Okay, it's not going to automatically run itself. So do you guys realize where we should call this function? Where should we call this function? That means where should we tell it to run? Yes. Okay, so remember that clock function on frame enter? Happens 24 times a second. We can run this function 24 times a second by calling it in that function, like we did for the ball movement. Okay. So remember that's called calling a function. Whenever we call a function, it goes to the top of the function, runs it to the bottom, and then returns. So what I'm going to do, let me make sure everybody got it, but I'm going to copy this function call so that I don't have to rewrite it. So I Control-C'd and copied that function name with the parentheses. When we call it, we still have to put the parentheses. Okay. And we'll go up here to our on-frame enter event. Where is he? Here he is. Here's our on-frame enter function. And we can add him right there. And so what will happen is on-frame enter, he calls the ball movement function. Remember that when a function call like this is executed, so when he sees this line of code, he goes, oh, okay, take me to the ball movement function. Comes down here to the ball movement function, runs that function from top to bottom, all the way down here, in order. And then when he's done with that function, he returns right here into our program. Then it calls the AI movement function. He'll come down to the AI movement function. He'll run this code. And then come back up here into our program. So you could have just copied and pasted all this code all into this giant on-frame enter function. But how can we make separate functions? Huh? It's easier to read, mostly. Okay. It's easier to modify. If we want the ball to move a different way, all we have to do is add another ball movement function. Okay. It's easier to edit because it's easier to read. Okay. So we should always try to encapsulate our logic. See, the ball movement was one part of our logic, so we encapsulated it into a function. Our artificial intelligence was another part of our logic, so we encapsulate it into a function. Okay, so it's important to do that. All right. But let's see if he works. See if we have any syntax errors. So I did a Control-Enter. When the ball's y value... Now, notice the ball went right through him because that's what we told our code to do, but he did actually move. Okay? We haven't told it to move off of the enemy yet. Okay, so notice that when the ball's y value gets above that paddle, he does actually move. Now, why doesn't it bounce off of him? Because we commented out that part of the code. Remember when we commented out that part of the code? All right, so now we need to make it bounce off of our enemy. So the part of the code that we commented out on Monday, let's go down here. It was in our ball movement function. Okay, so in the ball movement function, we commented out the added this part. So this is where we're going to add this part. So remember that if you used the comment code like I did, it'll be the /*, and we're going to go ahead and delete that. That was the beginning of our comment. And then all the way down here, that */ was the end of our comment. And because we named our enemy the same as this code that we copied and pasted, he should work. The only part that will not work is this right here, because we have not added any kind of internal animation to our enemy. So actually that first line of code, if you copied and pasted it from the file I gave you, will cause a syntax error because there is no wave on the enemy's timeline yet. We'll go ahead and make one in a second, but there is none right now. All right, so remember to save it, Control S, Control Enter, and run him. Oh, shoot, and then I died. We need that reset function. So we'll have to make our reset function soon. Okay. Oh wait, I got an error. So syntax error, remember that compiler errors are a good thing. A term is undefined. What did I do wrong? So it must be something with the code I entered. This is why we test as we go. And let's just look really quick. What would be undefined in here? Oh, yes. We haven't added a hit area to our players yet. And what a hit area is, just so you know, is when you have a player that's like weirdly shaped. Let's say you have like a human player like how I had in my demo video. Okay, I'm not a very good artist, okay? But let's say that this was our girl. Remember that her outer box is this right here. Okay, this is her hit area. So when the ball gets right here, it says that it's hit. But us visually, we can't see this outer box, so it looks like it didn't really hit the girl. So what I'll show you how to do, and it's in my videos, is we make like a little box inside of the girl right here. And we put it underneath her so you can't see it, but it's there. And we call this our hit area. And so when we test the ball, it'll wait till it gets to this box and then bounce off. And so then it makes our game play a little bit better because it's not seeming like it didn't really hit the girl. So if you make this little invisible box right here, we call our hit area, then the ball will hit that hit area and bounce off. Okay? And we can make that. It's actually really easy. Okay, you just make a little tiny movie clip inside of the girl and put it underneath her on a layer where you can't see it. But then you check to see if it's hit the hit area and not just the outer box of our character. When our characters are weirdly shaped, that happens. Okay, when they have like appendages that stick out. Okay? So that's what I had programmed right there. So we just want to put enemy now, because there is no internal movie clip of a girl with a hit area, but there is an enemy. All right, let's see if our code then will compile and run, and he seems like he's running. We're not throwing any errors. Oh, we made it too hard already. Now note that no matter where you hit the ball, because that enemy has no randomness, he's always going to hit the ball. He's never going to miss. because he knows the ball's y value and he moves to the correct location. Okay, so it's not going to be a very fun game because we're always going to lose. Okay, so you thought the enemy was going to miss right there, but no, he got it. All right. Oh, and I totally lost. All right. Sure. Let's look at that guy. All right. Yeah, in fact, we need to look at this function because now we need to add our randomness back in there so that we can actually win sometimes. So in order for us to kind of win and to make it more realistic, we have to make the enemy mess up once in a while, right? Maybe not get there fast enough. Not all the time, because then he'll lose all the time, and that would be boring too. Okay? So remember that with games, you have to add a randomness to it. Okay? It's that randomness that makes games fun. That's why we have dice and cards. It's that randomness. So we use that math.random function a lot in our games and in code in general. Every programming language has a math.random function. And so what I do is I put that math.random function right here so that it reads math.random times, that's the multiplication, the little star, 5, and then I add 1. And what is that telling me? All right, so math.random in ActionScript 3. If you ever wonder what a function does, remember that you can Google it. So I think it's good to look at the API. We've come far enough in this class. And I'll go back to my code in a second. But whenever you want to Google anything for like a programming language, you always put the name of the programming language. So ours is ActionScript 3, so I always put AS3 when I Google things. Before Googling, looking up programming languages was really hard. Now it's easy. You guys are lucky. So you just put AS3, and then you put the function you're looking for. Google's pretty smart. It brings open the API right here. API is usually first. Remember, this is called our Application Programming Interface. Okay, the API for any programming language is our directions. And you can look up things in here, and the more you look at the API, the better you'll get at programming. Okay, and the more it'll make sense to you. And we could read what this function does. Returns a pseudorandom number n, where n is greater than or equal to 0, but less than 1. And a lot of programming language will give you a random number like this. So what does that mean? Greater than or equal to 0 and less than 1? That means it's giving us 0.555 or 0.3. Or it can give us 0. Or it can give us 0.999999999. It'll never give us 1 because it's less than 1. But it is inclusive of 0. So it goes from 0 to 0.9999999. Okay? All right. So what kind of number is it going to give us? Let's look over here. So this is how we kind of use math.random functions then. We take that decimal value, so this could be 0 to 0.9999999, right? And we multiply it by 5. What happens when we multiply 0 by 5? It stays 0. What happens when we multiply 0.1 times 5? He's 0.5. What happens when we multiply 0.99999 times 5? Yeah, he gets really close to 5, but he's not exactly 5. So we're going to get a number here from 0 to very close to 5. Okay? And then we add 1. What happens when you add 1 to 0? It becomes 1. What happens when you add 1 to something very close to 5? Yeah, something very close to 6. So this is going to give us a number between 1 and something very close to 6. Okay? So that's how we're adding to our enemy y. So he'll give us a number, different numbers each time, between the range of 1 and 6. So he's going to give us either a 1, a 2, a 3, or 4, or 5, or a 6. or something very close to 6. Okay, so he'll give us some random number in there. Well, if you want to see that, you want to see how he's working, you can always trace the enemy's Y value. So remember that we use our console output to kind of test things and realize how our code is working so that we can modify it. So I can write in here enemies Y value in the AI movement function, or in AI movement. Okay, remember that's our string. We can concatenate it with his Y value. And remember that this trace statement does nothing in our code except print it out to the console, which just helps us debug and helps us realize how our code is working. So remember that this will be printed out 24 times a second, which might be a lot, but we could see his AI movement then. All right. So if we save it, and then we run him, so right now his Y value is at 250. You can see him moving. He does move at, between 1 and 6 pixels. Notice he's moving really slow, and then he kind of speeds up, and see now he's moving, not so consistently now. He slows and speeds up. If you want that to be a more dramatic change, what could you do? You could change this number 5 to something bigger. Okay, then he could move more. He'd have a more dramatic range that he could change from. Okay, so you could actually play around with the numbers here. I would change one number at a time when you're playing around with these. But if you change this to like a 10, the 5 to a 10, then he can move from 1 to 10 pixels. Okay. What if I wanted him to move between 3 and 8 pixels? This one you have to think about it a little bit. If I want him to move between 3 and 8 pixels, whenever you want him to move like between two numbers and it doesn't start at like 1 or 0, you think, how big is your range? Between 3 and 8 is 5. So I would leave the 5 there. But I want it to start at 3. So I would change my 1, this is called my offset. I would change this 1 to a 3. Do you see if I'm adding 0, something, remember that this is 0 to something close to 5. If I add a 3, it'll be 3 to something close to 8. So if you wanted him to move between 3 and 8 pixels, you could add a 3 right here. And now I've just modified that range that he can move. And do you see how you can kind of play around with these numbers? Maybe you have a different size enemy than mine, or you want it to play differently. It's good to play around with your code. That's how we learn too. So notice he's not going to move till the ball's Y value is above or below him. And you see now he's kind of more dramatic movement. And then if you don't want it to be, so dramatic, remember that you could minimize this range a little bit. If you wanted it to move between 5 and 8 pixels, what would you change your numbers to? If I wanted between 5 and 8. Now my range is 3. So remember that this is our range. We want it to go from 0 to 3. And then I want it to start at 5. Remember, your offset is 5. So then he would move between 5 and 8 pixels. So then my range isn't so dramatic, but he can actually move a little bit faster. And you could play around with, I really encourage you guys to play around with that a little bit. Okay. We'll see if we can get our games running a little bit differently. You could see which works. Okay. Doesn't work. Oh, I'm not very good at praying. I think we need a reset function. So then we don't have to keep restarting when I lose or when we lose. So that should be our next step here. Let's do our reset function, then we'll change our players, and then we'll take a break. Does that sound good? Make sure everybody's caught up. All right. So let me check to see if we had our reset function over here. So our reset function does have to reset some of our variables. So I'll leave this up here as we're working on it. Now you could copy these variables from up at the top. These are our variables from up above. So if you don't want to type all of these, remember that you have those variables up here. Remember that we instantiated them up here. So you could copy these. And then you would just get rid of the private var because we do not need to redeclare them. So if you copy these values, that's fine. You can copy them down to here. But get rid of the extra declarations because you do not want to redeclare the variables. We're just resetting them. We're setting them back to the values that they began with so that it'll start new again. Okay. So those were for our ball. You know, his ball movement, we need to reset all of those variables so that he'll start out new again. And then remember that the other part of our reset function is we just put the ball back in the middle. And then we put our player back in the middle. And then if you wanted to put your enemy back in the middle, you can too. So we're just changing all their Y values so that they're back in the middle of our screen. I put it outside of any other function, so I made my, actually I forgot to put public here. Let me make this properly looking function. Sorry. Notice that ActionScript lets us get away with making improperly written functions, but we should always try to strive for writing them correctly. So notice if I left the public modifier out, it is by default a public function. And if I left the return type out, by default it is void. But it's always good to write that in there, okay? Because this is a coding class. We're figuring this out so that when we go to another programming language, we know how to write these things, right? And so remember, I put this after all my other functions, but before the end of my class, it's a brand new function. Now, this function is not going to run until I call it. Remember how we have to call our functions in order for them to run? So we need to figure out when to run this function and then call him properly. You can think, when are we going to call this function? When do we need to reset? When our ball leaves the stage. So we need to have like a little branching statement to check to say, hey, if the ball left the stage, go ahead and reset. Okay? So, do you know where we would check to see if the ball left the stage? Where should we check that? We could either make another function or just throw it into our enter frame event so that we can check if the ball left the stage 24 times a second. So we'll check it on our on-frame enter event function inside of our timer. Okay. So you can even comment some of this stuff if you want to too. Remember that this one is resetting the ball movement variables. And remember that this part is putting the ball back into the middle of the stage. And remember this last part here is putting the player back in the middle. get rid of this guy here. All right, and we'll leave this up so everybody can get it. Now you could save and run your code. Remember that this is not going to reset yet till we actually call him though. But you could just see if it compiles right. Make sure you don't have any syntax errors. Remember, these are all just plain statements, so they all have semicolons at the end. And then you guys don't need this from event listener because we changed our code. So make sure we don't need that last bit there. Or you can save it and try to compile it to make sure there's no syntax errors. So if your code's been compiling so far. Okay. Maybe you guys already figured out how to put your reset function in, so if you finish typing this, go try to figure out where to put your reset function. You'll put it in your onEnter frame event. You can have a branching statement that'll check the ball's Y position. The Y position's outside of the stage, call reset. Remember, he can go off to the left and he can go off to the right. So you need to check both sides. In fact, here is a good place where we can use a logical OR operator. So we used our logical AND operation, now we can use our logical OR. Right. Most people got this. Remember, you can copy and paste those variables. Sometimes it's good to copy and paste the variables, then we get their spellings right too. Now remember, if you change these values, you put your changed values here, because remember I had you guys could play around with those values. So they'd be the same values that you started with. All right. If you had a syntax error, look for semicolons at the end here. Remember that this one is not minus equals. It is assign the value of negative. So that one right there. All right. So like I said, let's go to our onEnter frame event so that we can call him. So we call our ball movement. We call our AI movement. We can put that right here. We can see check if the ball has left the stage. And it's left the stage, then reset, right? So we're going to check that ball's Y value. If ball.y is greater than what? Actually, X value, sorry. X value. We're checking horizontally to see if he's left the left or the right. That's our X value, right? Our top. So if his X value is greater than, yes, greater than our stage width. And it's good to program it stage.stage width and not a number. So then when we change our stage width, our code will adapt. Okay, so stage.stage width. Oops. Okay. And here's where we're going to use our logical OR operation. So an OR operation connects two Boolean statements, and it's true if either side is true, which kind of works for what we're doing, if it leaves the right or it leaves the left. Okay, so we're going to check if it leaves the right on this one, or, so we put a line and a line, or ball.x is less than what? What's our left side? It is 0. Yes. So if he's less than 0, we know he's left the left-hand side of our stage. Okay. And then because we wrote the awesome reset function, all we have to do is call him. So then, okay, if you left the left or the right of the stage, you have to call him. Remember that we have to use these logical OR operators because a computer, its main limitation of a computer is that it can only check 2 things at once because it's binary. That's how we've created our computers. They can look at 2 things at once, not more than 2 things at once. That leads to a lot of algorithms for our data structures, why they work the way they do. Because computers can only compare A to B. So he has to compare A to B or compare A to B. So we connect those 2 Boolean statements with that logical OR. So it'll be true if either one is true. Note that we don't want an AND there because they both can't be true at the same time. That wouldn't make sense. Okay. So we can test him to see if he works. It's always good to run it. Oh, and I forgot down here, because I copied and pasted my code. I put player down here, but in my code I named him player 1. So you might have gotten that same syntax error. I got a syntax error saying, hey, I don't know what player is. Whenever you get a syntax error like that, it's usually because we spelled it wrong. Okay. So remember to name him player 1, because in this version of the game I named him player 1. In the old version I named him player, and since I copied and pasted it, it had the wrong name, which sometimes happens. Okay. All right. Oops, that didn't work right. So notice that he is resetting every time. So it's good when our code works wrong. Okay, because then we got to figure out why why is it doing that? So note that he's resetting each time. So that OR statement is becoming, that if statement is becoming true. Okay? So something's going on with our ball where he's making that if statement true. He's saying, yes, my x value is less than 0. Okay? So when something like that happens, we're saying, okay, the reset function is called. This is how we debug our code, right? We know that this is becoming true somehow. Okay, so our ball's x is becoming less than 0. Okay, so I'm going to look at my ball and see if I can determine why he is equaling 0, and I think I see why. When I go ahead and I look at my ball, remember that, so I went over to my flaw file, I double-clicked on my ball, and I could see that his crosshair here is in his top left-hand corner, so that's where his reference point is. So it's when his reference point says that he's 0 or very close, well, he must be hitting 0 or less than 0. Okay, so let's see if we can fix him. So I'm going to take my ball and I'm going to make his reference point the middle of him. And maybe this will actually be the reason our other code was kind of slippy. So I'm going to take my ball, and what I did is I double-clicked on the ball, so I was editing him, and then I moved my object so that his plus sign or his little crosshair here is in the middle of him. We'll see if that helps fix it. We'll save him. And we'll run him. Hopefully he won't reset. Oh, shoot. Okay, I missed him that time. Okay, so now he seems to be working a little bit better. We'll make sure he doesn't reset on this other side. All right. Oh, there I missed him. All right, he seems to be working a little bit better now. Cool. All right, so let's go over how to change your player out, and then and I'm just going to demo it, and I'm going to demo it a little bit fast, so if you don't keep up, that's okay. I'm just going to demo it, and then we'll take a break, and then you guys can work on changing your player up. Okay, so you can choose any kind of theme that you want. In the example online, I chose a little cat with a little human girl playing against each other. Which should I choose this time? Maybe I'll choose a superhero here. So sometimes when you're choosing your enemy or your player, should I make him the enemy or the player? You try to choose something with like a white background and maybe him kind of turn sideways because he needs to be, hitting the ball. This one looks okay. Oh, and it already has a transparent background. Very convenient. So if it didn't have a transparent background, I could get rid of the background with fireworks. So I'm going to save my image. And sometimes it's a good idea to save your image where your flaw file is so it's easy to find. And then I go over to my flaw and I open my file folder. The easiest way to import these images is to go to where you stored him and drag him to your library. Okay. And I can drag him out here. Now notice that his box is actually really large around him, so he's going to have a very large hit area. So actually I need to modify him first, to tell you the truth. Okay, so I'm going to delete him. I'm going to go over here and I'm going to open him with fireworks. You can open him with Photoshop. Some of my students prefer Photoshop. Remember that when you're editing your characters, you can use this magic wand tool and select the background if he had a white background and hit delete. So if you had a white background, you use that magic wand tool over here to delete your background. You know it's transparent when it has this little checkered mark thing. That means transparent. Now notice his blue box. And notice that when I imported him, it put the box around him right here. And so then that was his hit area. And it won't get near to him. That wouldn't be good. So in Fireworks, it's actually pretty easy to make our canvas smaller. You click anywhere off of him. And then this little button pops up, Fit Canvas. Voila. It shrinks down his his outside borders. So his hit area will be smaller. I can save him then. His hit area is still going to be rather large, so we'll have to add a hit area inside of him too. Okay. All right. So I saved him. Remember that when you want to save something with a transparent background, you have to save it as a PNG and not a JPEG. JPGs do not support transparent backgrounds. Okay, so you would just do File, Save As, and save it as a PNG or a PNG file. And then we'll copy him over here. I'll delete the old one, replace it. Okay. I then drag him out. He looks a little bit nicer. I can use my transform tool to make him a little bit smaller. In fact, I could have done that in Fireworks. I hold down my shift key. Should I make him my enemy since he's facing that way? I then F8 him. I could call him, what's his name? Does anyone know his name, huh? Wait, spell it? That's his name? Yeah. Oh, I haven't seen the movie yet. I'm planning on seeing it. Yeah. I don't know much about that. Okay. So we'll call him Deadpool. All right. I export for ActionScript importantly. Tell it OK. Then I can delete my instance from the stage. And then to change your code to use that object instead of my enemy type object, it's actually really easy. All we have to do is instantiate him and declare him. I type Deadpool then. So instead of making an enemy object, I make him a Deadpool object. So I declare my enemy, my new object type. And then when I come down here and instantiate him, I just instantiate him with his own constructor. I don't have to change the variable name. The variable name can stay the same. So voila, now he will be a Deadpool character.
We can take that added
Oh, you know what? I placed him on the screen maybe wrong. Is he over here? Yeah, he's over here. He got backed up too far. It's because, you know, when I placed my other object on the stage, so I just need to make him in the right place, so I would just change his X and Y's. Okay. And it's because he goes stage width and his, now I could just change where his little crosshair is to make it, so then I don't have to change my code at all. I could go over to my Deadpool, and remember where my enemy's crosshair was? It's in the back middle. So if I double click on my Deadpool character and I make his crosshair in the back middle, voila, he's in the right position now. So I just make his reference point the same reference point as my old enemy character. So then when I hit Control Enter, there he is. And then he's moving around. There he is. He moves like a little paddle. Now, if I want that enemy to have some kind of movement, I can make internal movement inside of my character. Remember that I would double click on my character to get into his timeline. Remember that if you want to add movement to a character, you should put it on an internal timeline. So I double click and I make sure that I'm in the Deadpool character's timeline. Okay. I then can add some stuff to his timeline to animate him. But maybe we should wait till everybody gets a character first before we do this step. Or should I just do this step and then you guys do it? What do you guys think? Yeah, let's get our characters first, and then we'll take a break. You guys can get your characters, and then we can figure out how to animate him. We would just add a couple layers, just like we've been doing like in our pizza animations and our other animations. You would add your action script layer and your labels layer. And I could do it really quick. Remember that he has to be an internal movie clip. I can tween him and do what I want. All right, but I think this is a good time to take a break, actually. So let me pause this and pause this.